Hey everyone, I am super excited to talk about this paper. And that might seem a little strange at first glance because it's not really about longevity. It's about blunting the effects of salt on blood pressure. And so yeah, blood pressure is a big deal. It's one of the leading risk factors for the leading cause of death in the Western world. So it is related to mortality. But to me, this is such a cool paper because it demonstrates something that in hindsight really should have been obvious. If you knew some basic physiological principles, this should have been a no-brainer. But it wasn't a no-brainer. And even after the paper's been done, you don't really hear anything about it. I only became aware of it listening to an interview of Richard Johnson, who's at the School of Medicine in, I believe, University of Colorado, Denver. And this is basically a study just looking at, what are the effects of drinking water with a meal? And it seems kind of like, why would we think that would even do anything? Why is that important? Water's healthy, yes, but, does it matter when we drink it? But if you know some kind of basic physiological principles, I'm going to try to do something on the fly here. Yes. Okay, just making sure that works. I don't think I've used paint since middle school. There's got to be a quicker way to erase this. But if you know some basic physiological principles, you know that concentration gradients drive movement of particles and solutes. So just imagine for a second we have a membrane, a cell membrane. And let's pretend there's a channel right here. And this channel allows sodium to travel through it. If there's a ton of sodium, oh boy, this is ugly. But let's just say there's sodium there's sodium cations all over the place out here, right? There's just a ton of them. Maybe 10x. That's kind of typical in the interstitial fluid. And there's, just a handful on the inside, dissolved in water. Which way is the sodium going to go? Well, this is called diffusion. It's going to go this direction. Let's say this is inside the cell, intracellular. So this is really responsible for a lot of sodium recommendations because we know that, hey, if you eat more sodium, you're going to increase the amount of sodium inside of your GI tract and your body's going to absorb it. And then sodium attracts water, so that's going to lead to bloating of your stomach after you eat a salty meal and cramping, and eventually after that all diffuses and makes its way into your bloodstream, it's going to lead to high blood pressure. And there's a lot of different pathways that influence that, and it's, sort of some complex physiology. But at the core, we're talking about a concentration gradient. Now, what should really have been obvious all along that, there's two ways to modulate this concentration gradient. One is to eat more or less sodium. That's going to either add sodium ions or have there be less sodium ions. But we can also modulate the amount of solvent that the sodium is dissolved in. And in the case of, humans, human physiology, that solvent is water. If we add water to the extracellular fluid or to the lumen of your stomach, let's say, then the sodium concentration goes down. And the force driving the sodium into your body also goes down. So that's like a pretty straightforward hypothesis to be tested. Does drinking water with a meal influence the amount of sodium you absorb? And if it does, should we be spending so much time telling people to eat less salt? Should we instead just be saying, hey, have a glass of water with your salty meal? And then this is going to pave the way for some other videos in the future talking about, is salt even really the culprit in hypertension? And that's a big, sort of debate in healthcare literature. Sort of the conventional wisdom is, yes, absolutely. But there's some really amazing writers. Taubner, I believe his name is Gary Taubner. He's kind of made a career out of identifying bad science, and he's done a lot of really interesting work about, sugar versus salt. What really drives high blood pressure and obesity and diabetes and heart disease. But I'm getting off topic. Let's get back to this study. So this study is basically, we're going to have people eat a bowl of lentil soup. I'll just actually go down to the 4 conditions. Here we go. Have people eat a bowl of lentil soup with no added salt and no water. Then we'll measure their blood pressure before and after. We'll look at a bunch of different things. Plasma sodium, osmolarity, and a copeptin, which is a enzyme, I believe, that regulates vasopressin, an antidiuretic hormone. So really, to me, the most interesting thing is plasma sodium and blood pressure, or at least the easiest for me to understand. So anyway, we're going to look at someone eating soup, no water. Soup with added salt and no water. Soup with added salt and 500 milliliters of water. Soup, added salt, 750 milliliters of water. And they're drinking this simultaneously. So they're drinking water, eating, drinking water, eating. Okay. So let's go down to this figure. It's looks chaotic, but if you remember back to the 4 conditions, the red line and the black line and the red line are the soups with let's go to blood pressure. So the black line and the red line are eating soup without water. The green line and the blue line are eating soup with water. And we'll go into more detail first, but let's start with blood pressure. So red, the biggest spike in blood pressure came with soup, added salt, no water. Pretty dramatic. The other 3, so black, green, and blue, this is soup with no salt, soup with added salt and water, soup with added salt and a little bit more water, are essentially the same. Actually, the green and blue lines, if you look at this profile, I believe this is over 4 hours. For a lot of this time, it's actually below the black line. So what this is saying is that you can actually have more salt. You can eat a meal with more salt in it than somebody else. But if you drink some water, you're going to feel less of the effects of sodium. So this is kind of paradigm shattering, because what this says is that the absolute amount of sodium you consume is not what's important. What's important is the sodium concentration, in your stomach and intestines during and after a meal. And you can influence that dramatically by drinking water. Or just, maybe when you make your soup, you use twice as much water or whatever. So the point is, you can eat something salty. If you're going to eat something salty, drink water with it. And then you see similar stuff over here with osmolality. So, that's interesting. All of these are interesting. But to me, blood pressure is of all these, the risk factor for heart disease. So I want to know, how does the food I eat impact my blood pressure? Well, again, we've learned that it's not so much how much sodium you eat, but if you're drinking water with the sodium. And I believe they found that this effect is not as dramatic if you drink water after. And it doesn't just have to be water. It has to be something, relatively isotonic like water. It could be tea or other drinks. Then you're better off having a saltier meal and drinking a glass of water than eating a low salt meal without water. So it's kind to me, that is shocking. What is, I think, more interesting about this is that this concept should apply to other compounds. Now, it's kind of most obvious with sodium because sodium is a simple cation, but it could also apply to molecules like glucose and fructose. And if that's the case, we might be able to modulate the glycemic index of something, you know, the rate at which you absorb the sugar or how much sugar you absorb based on, you know, drinking water with that meal. I don't know. That's speculation. But to me, that would be an interesting follow-up study. So what is the point of all this? Well, I mean, I guess, yes, of course, you should be drinking water, but more importantly, drink it with your meals. And if you decide to eat something incredibly salty, have a glass of water with it. I'm going to go make a pastrami sandwich, I think. See you guys. Bye.